Assalamualaikum everyone. We are students from UITM Place Aro campus will make a tutorial for group assignment MAT183. This group assignment will carry off 20% marks of it. So please, every one of you, please like, share and subscribe to this video. We also hope you are clear with the tutorial. First of all, we would like to introduce our member name. First, my name is Muhammad Arif LUQMAN bin AKMALUDDin. My matrix ID is 2020452458.
My name is BADRULAMIN bin ZULKIFFLI. My matrix ID is 2020874838.
Hello everyone, my name is Didi NATASHA with the SAWI. My matrix number 2020452108.
Hi, my name is IRDINA with SALINI. My matrix ID is 2020821414.
Hello, my name is MOHAMAD HAQIEM bin BAHARSAM. My matrix ID is 2020833184.
And we are from the same course code, which is CSC 110, group RCS 1102A to Christian.
Before we start, there have 4 topics given. The topic is application of differentiation related rates, application of differentiation maximum and minimum problem, application of integration area between two curves, application of integration volume. So, the topic we choose is application of differentiation related rates.
Before we explain more about application of differentiation on related rates, let's look into the situation first between AMAR and ALIYA.
Hi ALIYA, happy birthday.
Hello AMAR, thank you. Come in and enjoy the food.
Okay ALIYA, how about after we eat, we play balloons?
Good idea, okay.
ALIYA, why are you curious?
Nothing. I'm just curious about this balloon.
What?
I was thinking, if I inflated this balloon, what is the rate of radius of the balloon if it is changing?
Wow, simple answer for easy question. This is application of differentiation problem.
Can you explain?
Yes, sure. Before we get into application of differentiation more, let me explain to you what is differentiation. Differentiation is a process of finding the derivative or rate of change of a function.
There are 4 basic derivatives. The first one is algebraic functions. Algebraic function is a function that can be written using a finite number of the basic operations of arithmetic, addition, multiplication, and exponentiation. In order to take the derivative of this function, we will need to use the power rule. The power rule states that if f of x equals to x raised to the power of n, which is any real number, then f prime of x equals to n multiplied by x raised to the power of n minus by 1. Next, we have trigonometric function. There are 6 formulas that can be used in application problems of the derivatives. The rules are summarized in this example as follows. If f of x equals to sine x, then f prime of x equals to cosine x. If f of x equals to cosine x, then f prime of x equals to negative sine x. If f of x equals to tan x, then f prime of x equals to secant squared x. Next. And logarithmic function. with base e have derivatives of the following form. If f of x equals to log e x, then f prime of x equals to 1 over x, or log. An exponential function with base e is its own derivative. That is to say, if f of x equals to e raised to the power of x, then f prime of x equals to e raised to the power of x as well.
Differentiation can assist us in resolving a variety of real-world issues. We use the derivative to figure out what a function's maximum and minimum values are. The other examples are cost, strength, amount of material used in a building, profit or loss. A related rates problem is a problem that involves at least two changing quantities. The question should ask us to figure out the rate at which one is changing given sufficient information on all the others. The idea is to find the rate of change of one quantity in terms of another quantity whose rates of change are known.
For the example, in the dialogue we just heard, we can state the problem is a spherical balloon is being inflated at a rate of 8 centimeter power of 3 second power of negative 1. Find the rate when the radius of the balloon is changing when the radius is 10 centimeter. So the solution of this problem, the first step you must do is we must state all the information that has given to us. First, the question has given us the volume of the sphere, which is 8 centimeter power of 3 second power of negative 1, which is dV over dt. And the indication also asks us to find the rate when the radius of the balloon is changing when the radius is 10 centimeter. So, dr over dt equals to unknown. The answer we must find when the radius is 10 centimeter. So, how do we find the rate of changes, which is dr over dt, is we must use the chain rule. First, just write the equation dr over blank space or something multiplied by something over dt. So the equations already gave us the volume of the sphere. So we can just fill in the blank space with dV, which is the volume. So before we go further, the formula of sphere volume is equal to 4 over 3 pi r power of 3. So if you want to find dV over dr, which is the differentiation of the formula, we must put the power in prime, multiply by the equation, and the power minus by 1. So we can simplify it and become 4 pi r power of 2. Right? In this chain rule, we must use dr over dv. So if you want to find dr over dv, we can just change the position of the equation, which means we can get it 1 over 4 pi r power of 2. The third step is to substitute the amount in the same way that we already write. So dr over dv equals to 1 over 4 pi r power of 2 multiplied by dv over dt, which is that already as given from the questions, is 8 centimeter power of 3 second power of 1. So we can get the answer 8 over 5 8 over 4 pi r power of 2. And we can simplify it, divide by 4, and we can get the answer 2 over pi r power of 2. But that's not the last answer, because the answer asks us to find the rate of changes when the radius is 10 centimeter. So how do we find the rate when the radius is 10 centimeter? We can substitute the radius amount that is given to us 10 centimeter to the rate that we just write, which is dr over dt. So we can substitute it to the amount of r, and it became 2 over pi multiplied by 10 power of 2. And we get the answer 2 over 100 pi, or 2 pi 100, 2 over pi 100. So we can simplify it by divide by 2, and we can get the answer 1 over 5 pi, 1 over 50 pi. So the final answer is 1 over 50 pi centimeter power of 3 second power of negative 1, or 1 over 50 pi centimeter cube second power of negative 1.
The conclusion is, by using a related rate, we can know how the variable is changing by knowing how fast the other variable and what is a relationship between the two variables. Related rate usually involve with writing an equation relating the two variables and using implicit differentiation to take derivative of the equation with respect to time. So, there's our reference we refer. Thank you for watching this video. Bye.